My name is Robert Wang, and I joined ASU in the August of 2011, and I joined the School for Engineering of Matter, Transport, and Energy. Within that, I am I'm a program faculty in mechanical engineering and graduate faculty in material science and chemical engineering. My most recent research has probably been in the area of thermal storage. So the idea behind thermal storage is actually kind of similar, be analogous to, say, a battery. So a battery is basically a box. You put electrical energy in, and that box holds that electrical energy, and later you get that electrical energy back. So thermal storage is not storing electrical energy, but instead we're storing thermal energy. So you can say, if you do thermal energy storage well, you can maybe take the heat from the day and use that to heat your house at night. Take the cold from the night and use that to cool your house during the day. If you do it really, really well, you can potentially take the cold from the winter and use that to cool your house in the summer, and take the heat from the summer and use that to heat your house in the winter. It turns out, I'm interested in energy overall, and if you look at energy and energy landscape of the U.S., thermal energy is a huge part of that. Probably 90+% of our energy is produced using heat engines, things like burning coal, nuclear power plants, burning gasoline in your car. Those are all heat engines. That's basically 90% of your heat. Even on the end usage side, a huge amount of the energy bills people encounter are using heat. Air conditioners, heaters, hot water heaters, refrigerators. It turns out industrial production, concrete and steel and glass use, I think something like 10% of the energy in the US. And that's all heat. And so I think there's a lot of opportunities there just by the sheer magnitude of thermal energy we use. I'd always enjoyed education. I was tutoring friends dating back to junior high school. And then in college, I did two separate extracurricular activities. One was I did research with some faculty members just at UCLA. And another thing I did was I tutored immigrant children English on the weekends. And it turned out being a faculty member was a great way where I could combine both. And the natural fit for that was, since I was engineering, was to be STEM. Stereotypically, when I was a teenager, I loved to take things apart, put them back together. It became fascinating to me that a bunch of seemingly useless objects could be put together to do something useful, such as make an automobile. But at the end of the day, it's just a bunch of chunks of metal and rubber that would seemingly be useless as individual pieces. First of all, pursue something that intrigues you. The beautiful thing about science and engineering is the job opportunities there are great, and consequently the opportunities to be able to find a job in something that excites you, are there. If you love automobiles, there are lots of jobs in automobiles. If you want to if you want to do healthcare, there are tremendous opportunities for engineering and healthcare, and science for that matter too. Even if you love business, for that matter, the filmer here is a math major, and the opportunities to use math within business are tremendous. So I would say, the best way I think to lead a happy life is to find something you love and pursue it. And fortunately, in the case of STEM, you can find a nice, high-quality, high-paying job in the process. So.